Hi folks, this is part 2 of the automated bale wrapper series. Today, I've got the wrapper pulled into the barn, hooked up to the tractor. So for those of you who haven't seen one of these working like this before, this would be the dump position. You lift up on the 3-point and this frame lifts up. And on this pivot point here, the deck flops back and your finished bale rolls off. Basically, the fundamental idea of turning this into an automated system is to, one, alleviate the need for a big enough tractor. Because, for example, sitting out there is a John Deere 5210. It's a great little tractor, and it runs the wrapper perfect. But that machine doesn't have four-wheel drive, doesn't have a loader, doesn't have front weights. And when you pick this up, this whole contraption weighs 1,300 pounds. It picks up the front tires of the tractor, and just driving around here on the farm, it's not too bad. You can steer with your brakes if the wheels are starting to fully come off, but you definitely couldn't go down the road with it like that. So by converting this into an automated system and having some sort of stand or trailer underneath of it, the idea is then that, you know, any tractor could pull it. You know, this little 140 could pull it. The skid steer could pull it out to where it needs to be. You could pull it behind a pickup truck, doesn't matter. It'll have its own power plant, its own gas engine running a hydraulic pump that'll run all the functions of it. So it doesn't need to be connected to anything else. Just needs fuel stuck in the gas tank. So I've been sort of torn between the idea of doing a fixed stand where you would still pick it up and move it with the 3-point. Because generally what's going to happen, I'm thinking, I'm making some assumptions here, but generally what would happen is I would finish baling, I would come back to the farm, drop off the baler, grab the wrapper here, hook it onto the tractor, put the bale grapples on, grab a bunch of plastic like you see sitting there, and go out to the field and wrap. Or we would maybe haul hay back, and it would just be sitting stationary here at the farm, and as I was unloading the wagons, I'd be running it through the wrapper and stacking it. But the thought that I had with the stand is that I always still need this tractor to move it around. What if I've got a neighbor that just put up some hay and wants to rent the wrapper for the day or the afternoon or whatever? I still have to take the whole tractor over there just to drop it off, because maybe they've got their own setup and they don't need the tractor. They don't need the squeeze or something, or, you know, they're only doing 20 bales and they'll just leave them in a row. Well, it kind of throws this whole thing off. Or maybe say I'm like, it's not uncommon when we're doing hay all the way to the north up there, almost an hour drive away with the tractor. We will get a tractor and a truck up there, so if something happens while I'm baling, I have a truck available and I can come back. So we plan ahead for all this happening. Well, in that circumstance, the tractor's already sitting at the field. If I want to come back to grab the wrapper, or what I could do is I could put the baler behind the pickup and drive that back, put the wrapper behind the pickup and take it back. And instead of that being almost 2.5 hour runaround, I could probably do that in close to an hour. So there's potentially a big time saving factor by having this as a trailer and not as a stand. Funny enough, I was actually planning to turn this into a trailer like 2 years ago, just so we could run it behind that John Deere that's sitting out there. So I had kind of collected some of the basic pieces that I needed to do it. I grabbed the tire here. What I found was a set of these old tires. The other one's in my pickup. And these I bought, they're not particularly good tires, but the idea was that these are a pretty good size for, and they got the right weight rating for moving, if this was trailerized, moving this contraption. So what I have in mind here is that there'd be a tire on either side, sitting just about there. So far enough out that it clears the drop portion of the deck, far enough forward that it clears the deck there, but far enough back that when the safety lock is engaged and there's going to be a hydraulic cylinder to control the tilt deck, when that's sucked in all the way, that this is far enough back that it doesn't still want to tip backwards. We're pretty close to that edge. I don't have a great way of testing the balance, the tipping point of all of this. I kind of have to like build it and find out. But I'm reasonably confident that that location for that tire will work. I might go grab the stand so I can jack this up to double check all the geometry, but that's the general principle. The thing we have to figure out now is how much steel do we need to connect this. So underneath of this is a 2x4 square tube. We're gonna go with a 2x3 by 1/4 inch wall subframe. It's gonna sit directly underneath of this, running up forward, coming forward a certain amount, enough room for the power unit and everything to sit right here, and then continue forward to a tongue for connecting to the trailer, or connecting to a tractor, a pickup, or whatever. So there'll be at least one cross brace that's going to be underneath. It can't be, well, it'll run, if the square tube is sitting right here, it'll run straight across there or somewhere back here maybe. I don't know exactly where. Those are just going to be scrap pieces. Those won't be the same 2x3 because they don't need to be. They're just tying everything together so it can't walk around out the back. This will be a 2x3 piece with a hole drilled in it big enough for the axle stub. I just bought these like generic spindles that'll slide through and they'll get welded in, and then the hub face will mount the tire right about there. Yeah, I'm trying to think of what else goes into this. There is the hydraulic assembly that's going to have to get added to this. The way that that's going to work, I've already figured that out, is there's going to be a plate that is going to sit right here, and it's going to be through bolted to this. And a big important part of this process for me is that I want to be able to turn this thing back into a 3-point wrapper at any point and super easily. My big thing is that if we upgrade wrappers at some point, if I can't sell this as an automated system, I just want to be able to revert it back to an Anderson RB200 and I can go trade it off to the dealer. No worries. So a lot of the modifications, I want to minimize how much welding I have to do on the physical machine. So these ones are going to be through holes, and then there's going to be a tab, 2 tabs that come out where a pin will slide through and the hydraulic cylinder will grab onto that. On this side, this is a little bit harder. I think this may end up getting welded on a plate with actually a 2-inch receiver for like making your own hitch in a pickup truck. That would then just have a pin that goes through it and a big 2-inch stock piece that's going to come up and out, and at the top of that another 2 tabs that the top of the hydraulic cylinder will connect to back down to here. So you could still run it just with the tractor and use the tractor hydraulics to cycle it, or you could just pop that cylinder off, use it as a regular 3-point wrapper. But when it's in its trailer configuration, then yeah, you'd have a power plant with it. I'll be able to test all of the kind of the trailer function and the dump function just using the tractor hydraulics before I have to build the power plant unit to run all of this. So the things I'm going to figure out right now so that I can go back and start plugging some of this into SketchUp and figure out exactly how much steel I need is I need to know the length of the frame here, which I'm actually going to measure on the... No, measure on this side, but switch hands. I'm going to grab from the back of that to the front of the frame here, which is 47 inches just about. If we come all the way forward, the center line of that pin looks to be just about 4 foot. This portion, which is much harder to kind of gauge how long it needs to be, looks to be about 16 inches. Yeah, because that would be 16 inches right there, depending on the angle that it's cut at. But that's 16 inches probably would be pretty comfortable, especially because the frame is actually lower. But if I account for 16 inches, then I won't be cut short. This front portion is more of a made-up number. Oh, and I guess we need the outside to outside of this frame is it's kind of hard to get the cylinder to grab the tape measure to stay put. We're at 30 3/4. So that's what the cross brace pieces would be. There probably needs to be one towards the back. I think one right underneath where these the 3-point connections are, because these are part of what will hold the assembly down. I'll make or weld tabs that come from the bottom plate up to these hole positions, and then I'll bolt through them, and that'll hold the front down. The back, I'm not quite sure what I'm gonna do. I might just drill and tap a couple holes here in the back, so that I can have a tab that comes up from the trailer underneath and overlaps and then gets bolted through. This front portion where the power plant and everything is gonna sit, you know, it'd be nice if that was probably 2 foot. And the more trailer there is to the forward of this, the more weight there is to balance the deck. Because a big concern I have is that maybe this thing is really well balanced and rides really good, but when you put a bale up on the deck, it just flops backwards. That's something I don't want. If it's hooked up to a truck or a tractor or something, the tongue would stop it from going too far. But it would be nice to be able to just pull this into the field and not have it hooked up to anything and just have it sitting out the middle. You know, the back weight on those tires, and then a good jack or two in the front to keep everything stable. So it's a bit of an experiment, but we'll say we're gonna come 2 feet forward from there. So the deck portion of these would be 6 foot. And then I have to decide if I want just a, I don't know how to like draw this out, but if the tongue is like this and comes together at a single point with 2 triangulated beams, or if it's just a single bar that comes back and is welded to the face and then it's braced. I know it would definitely be stronger to do a triangulated. Some of the question will be how much material I have left. If I buy, like, say, a 20-foot stick, I'll have to kind of sit down and do the math. If I have enough for a triangulated system, yeah, that would be preferred. But if I got to skimp a little, that's fine. If this was a tongue, that would be perfect if it was 2 foot. 2 foot from the front. They do say if you're pulling like a big trailer or something behind a pickup, 3 foot would be like for a standard standard trailer on a regular, half-ton, three-quarter-ton pickup truck. If you were pulling behind an RV or something else extra wide, a big dually or something, they say a 4-foot tongue from the front of the obstruction to where the hitch point is generally what you want to go for. A 4-foot tongue on this would make this whole thing feel really long, especially because the trailer itself is not very wide. That kind of tongue length stops being super relevant because you can turn much sharper before you get into the corners of the trailer. So probably something, about a 2-foot length stem coming off, and then that's where the hitch point is. We'll do something, perfect world, we would do something like this where it's an adjustable, and it's the agricultural style pin connection rather than a pintle or anything else, because most of the time this thing's probably going to be getting pulled behind a tractor. So that's sort of the general gist of what I'm trying to do here, how I want to set this up. I do need to reference the height here so that I know. We're probably just about 20 inches off the ground. So we'll assume that is a good height, which actually would work out perfect. The hitch height for this tractor is centered right at 17 inches. If this was 20 inches up and we had a 2x3 frame underneath, that would put the hitch height dead at 17 inches. So this thing would be pretty well balanced when it was getting pulled behind this tractor. It wouldn't be too far forward or too far back. This does generally need to be pretty level when you're operating it, so that having the tongue height be adjustable is actually important. But if it's got a good quality jack, or maybe 2 jacks, that wouldn't be the end of the world. I could put it at the front of the frame on both sides, put jacks on both sides, which would help to get this thing level in the field, both back and forth and side to side. So maybe that's what I'll plan to do. And then I have the frame just come straight forward to be at the hitch height to match this tractor. My pickup truck has got an adjustable hitch for going up and down, so I don't generally need to worry about the height for it on there. And yeah, I think this gives me enough information for me to jump into SketchUp and make a quick basic model of what this is going to look like, all drawn up, and from there I can calculate how much steel I need, and I can jump online and get some ordered. All right, so I just wanted to show you before the end of this video what the frame looks like. I know kind of talking about it's sometimes hard to track on the reality of it. I can see it in my brain, you guys can't. So this is it in SketchUp. Might still do a little bit of tweaking, but this is generally the layout that I'm doing. I'm trying to keep the total steel purchase for the 2x3 tubing to under 20 feet, because that's what the closest person I can buy it from at a good price. That's the length they sell it in, 240 inches. So there's a couple of things in here that I think I would do. I know in the other video section I said the cross braces wouldn't be 2x3. I think the front one does need to be 2x3. And I would prefer the back one to also be 2x3, but that tips me over the edge of that put me at 21.25 inch. You need a couple inches for the cuts and all that stuff, so couldn't quite make that work. If I can find a 24-foot stick, that'll sort of change the math here. But what I have in fundamentals is two 6-foot main beams that run down either side. I have some heavy wall 2x2 square tubing here in the shop already that I can use for cross braces. There's one at the front. The wrapper will sit on this back portion. Will be one as far back as I can physically go without interfering with that the tilt function, and then one as far forward as I can go. There's like these hoops for picking up the wrapper with like pallet forks or something, and they kind of sit towards the front of the deck, so as far forward as I can go without interfering with those. The front cross member will be a 2x2 or a 2x3, and then the main tongue stem will be 2x3 with some diagonal bracing to help support the whole thing. This trailer is physically longer than it needs to be, but I'm still worried about the tipping point, the leverage point of that deck, especially once it's got a bale on it, or like a big heavy 1,200 pound, 1,300 pound baleage bale. So the thought by making it longer, I'm just adding more weight to the front to counteract that. And having this additional space in the front, if I need to, I can actually install a weight rack, like a suitcase weight rack, off the front of a tractor to add additional ballast to keep this front heavy enough, or to balance the tongue weight as best I can. I have this spec'd out with 2 jacks on either side. These are just my quick... made some jacks in SketchUp so I could physically see where they would go. They're not exactly lined up. They would just go somewhere up here. They'd probably actually be a little bit farther back so that when the jack is rotated up in its transport position, the handle is well past this back corner. Yeah, the braces will be 2x2 for the front here. The tires that I have for it are 20.5 by 8. I have to double check that the spindles that I got are big enough. The tires that are on those are just 1,100 pound. I can get 1,500 pound rated tires, so if and when I build this and it all works out, I'll order a new set of rims and tires for it that are at a higher weight rating. Yeah, that is the SketchUp version. If you're not familiar with SketchUp, it's not great for modeling mechanical equipment. You can't do like moving pieces or anything in it, but for general just layout, trying to figure out the spacing of stuff, works really well, and it's really easy to use. It's free to use, the SketchUp online, so I do recommend it if you're just trying to play around a little bit with 3D digital modeling. Thanks for watching part 2 here. Questions, comments, concerns, all that sort of stuff, stick them down in the comments, and I'll do my best to get back to you. Thanks for watching.